Okay, first thing we're going to talk about is the shear diagram. Okay? Before we get to the actual diagram relative to shear, what I want to talk about is just the basic definition of what shear is. And the basic definition of shear is the sum of all forces or loads on a beam to a certain point. Now that certain point could be any point you choose. I mean, if a beam is 12 feet long, you could do a point every inch if you'd like. But I mean, a lot of times we think in feet. So, you know, what is the shear force on a beam? The definition is simply it's the sum of the forces on that beam up to whatever point you're considering. All right? Let's see how this works in real basic, in a real basic example. Okay? I'm going to say we've got a 10-foot long beam, and I'm going to say we've got 1,000 pounds acting on that beam right in the middle. Now, I just want you to think about that definition that I just gave you. The sum of the forces on a beam up to a certain point. First thing you got to do, and you have to do this correctly, is you got to do the reactions. Okay, now this is a pretty easy one, so I'm not going to go through all the equilibrium equations. I think you can tell me if I got a 1,000-pound load sitting in the middle of a beam, that half of it's going to go to the left support and half of it's going to go to the right support, right? Okay? But anyway, I want you to think about this. What if I was considering a point that was 1 foot out from the left-hand support? What would the shear be at that point? So what I'm saying here is, let's say I had 500 pounds here, and considering a point 1 foot out, the shear definition that we just gave you is the sum of all forces up to that point. Look at that free body and tell me what the sum of all forces is. 500. Which way does it act? Up. So we could call that positive if we wanted to. All right? So, you know now that the shear force 1 foot out from the left-hand side is 500 acting up, or we could say a positive 500 pounds. Okay? What if we were looking at a point that was 2 feet out from the left side? It would be the same thing. It would be plus 500 or 500 pounds up. What about 3 feet out? Same thing. 4 feet out. In fact, the only time it's going to change in the first 5 feet is when you get to where? The center of the beam. If I go out to the center of the beam, which is 5 feet out now I've got this 1,000-pound load. What happens to my shear? Negative what? 500, because the sum is I got 500 acting up, I got 1,000 acting down. At the 5 foot mark, it would change to negative 500. Okay? What would it be at 6 feet out? 7 feet out? 9 feet out? What happens when you get to the end of the beam? Gets to 0. Okay? That was a real simple example, but you answered every question correctly because you went back to the basic definition, the sum of all forces up to a point. All right? Now all we got to do on our diagram, for our shear diagrams, we just got to map out all those answers you gave. Okay? So here's the deal. We have underneath, I'll call this the load diagram, but again, the load diagram has the reactions on it. Okay, I'm going to draw just some leader lines down. I'm going to put a horizontal line that stands for zero shear, and a lot of times we denote shear using the letter V. Okay? So, Sam, what did you say? You said at the beginning, if I was to look right at this point, 0 feet out, what would the sum of all my forces be? 500. Be 500 up. Okay, and then it really didn't change until I got to the midpoint, and then all of a sudden I dropped down to negative 500 pounds. Then it really didn't change until I got over here to the support, and now I'm back up to 0. Congratulations, you just did your first shear diagram. Okay? What did that shear diagram tell us? Well, it tells us that the shear in the first 5 feet of the beam is 500 pounds. And we said positive, that's fine. And the shear in the second 5 feet is a negative 500 pounds. Now, again, that's pretty basic, but the other shear diagrams will be much more descriptive. I mean, you'll see changes occur and so on and so forth. So, let me do this for you. I gave you a definition of shear, and you used it, and you came up with a diagram, and it's correct. What did this diagram teach you? What were the main points of this diagram? Number one, shear diagrams always start at 0, and they always end at 0. Second thing, with concentrated loads, that's where you're going to see the shear diagram change its magnitude. At the reaction, I went from 0 to 500. Look at that. At the 1,000-pound load, I went from plus 500 to negative 500. A change of how much? 1,000. Down here on the right-hand support, again, concentrated load. What was the change? From negative 500 to 0. Okay? Concentrated loads, you'll see that shear diagram move straight up and straight down by the magnitude of the load. Okay? The other thing I like to do is I like to talk about, hey, think about the shear diagram this way. You know these values that I'm putting up here, 0, 500, negative 500? Those are like a scoreboard, like in a basketball game or a football game. Okay? Think about this. All the shear diagram is you are accumulating loads and forces. So you step onto the beam. What's the first load? At 0 feet, what's the first load you pick up? 500. Are you picking up any loads through here? No, so the scoreboard's staying, hey, we got 500. All of a sudden you get over to the midpoint. What happens? You just picked up a negative 1,000 pounds. So what does the scoreboard read? Negative 500. Anything going on here? The scoreboard's staying the same. You get over to the end. You pick up the last load. Now the scoreboard says 0.